those guys who have joined online, just inform your friends, join this class, hail the class. Online guys, are you getting my audio?
Yes, sir, will inform.
Online guys, somebody please respond, guys, online.
Yes, sir.
You're getting my audio, right?
Yes, sir. It's clear.
So please ask everyone to join this class.
Yes, sir.
Just one of you put your message to it. So guys, let's start the discussion. So in the last class, we made a discussion about the various number systems and how you can convert from one number system to other number system. Okay, we have seen how the conversion process happens whenever we are dealing with integer numbers and whenever we are dealing with fractional numbers as well. Okay, so anybody has any doubts there in that discussion? Online, offline guys, anybody? Everything is clear, right? Okay. So let us go further in that discussion. So in today's class, we'll start something about the complements of a number system. Okay, how can you get the complements of various number systems and how you can use them for doing some arithmetic operations. Okay, that will be the topic of discussion today. So online guys, just ask all your friends to join this session. Now. Next hour will be discrete mathematics. Some problem in the timetable. So the next important topic which we want to understand is complements. Okay. So what is the importance of complements? Okay. So as you see here, can you see that offline guys? Online guys, are you able to see the PDF
Yes.
which is shared?
Yes,
Yes,
sir.
sir.
So basically, complements are used in computers mainly whenever we want to do subtraction operation. Okay. Normally, when you do subtraction, internally we use this concept of complements in order to subtraction operation. Okay. So that is the importance of complements there. So basically, whenever you want to do subtraction, you try to use the complement of that number system in order to do subtraction operation. Now there are two types of complements as we have just briefly introduced in the last class, based on the radix of the number system. The first one is referred to as radix complement or simply R's complement, where R is the radix of the number system. In the case of a base 10 system, it can be R's complement will be tens complement, and the other one is diminished radix complement, which you can refer as R minus 1's complement. So in that case, it happens to be for the decimal number system 9's complement. So in this way, any number system you consider, there will be two types of complements which you can define. One is called as a radix complement or simply R's complement. The other one is referred to as a diminished radix complement or simply R minus 1's complement. Okay. So let us understand what is the diminished radix complement. So let us formally define how do you get the diminished radix complement. Given a number capital N in base R having smaller number of digits, the R minus 1's complement of the capital number N is defined as R power N minus 1 minus capital N. Okay, suppose if you are given a number capital N in base R system, then the R minus 1's complement of this number capital N is defined as R power N minus 1 minus N. This is how you define the radix complement, diminished radix complement of the number system. First, we are talking about diminished radius complement. Okay. Now, okay. So r minus 1's complement. So r minus 1's complement is defined as r power n minus 1 minus n. This is how you define your r minus 1's complement of a number, yeah, r power n minus 1 minus n. Are you able to see that? R power n minus 1 minus n. Okay, where n is the number which is given to us in a particular number system. Okay, so this is the first complement, which is called as diminished radius complement or r minus 1's complement simply. Okay, now let us have the definition for the other complement as well. The other one is r's complement. So the r's complement of a n-digit number, capital N, in base r is defined as r power n minus n. So let us write the definition for r's complement as well. So this is r's r minus 1's complement. Now write r's complement. So the r's complement is defined as r power n minus 1 minus n, sorry, r power n minus n. R power n minus n. R power n minus 1. So that is how you define your diminished radius complement and r's complement. Okay. Now let us try to understand some examples here. Okay. Take the example of a number. So r power n minus 1. In the case of diminished radius complement, if for the case of decimal numbers you could talk about, the radix will be 10, right? The radix will be 10. Therefore, r's complement will be 10's complement. Okay. In the case of decimal numbers, what is the base of the number system? The r equals to 10. So the r's complement will be 10's complement. R will be 10. Therefore, r's complement will be 10's complement. So r minus 1 will be 9 there. So the diminished radius complement will be 9's complement. Okay. So the 9's complement of n can be represented as 10 power n minus 1 minus capital N. So in the case of a decimal number system, r takes the value 10 there. So I am replacing r with 10 here. So the definition now changes for 9's complement of the decimal numbers. N is 10 power n minus 1 minus 8. So what is 10 power n minus 1? So 10 power n is 10 power 4 if you consider, 10 power 2 if you consider. 1 followed by how many zeros will be there? 2 zeros. So 10 power 3 will be 1 followed by 3 zeros, right? So what you are doing there, r power n minus 1. So when you subtract from 100, if you subtract 1, what will be the value? 99, right? You subtract 1000 from 1, what will be the value? 1 from 1000, what will be the value? 999, right? So in order to get the 9's complement of a decimal number, what you have to do is just based on the number of digits of the number which is given to you, you have to subtract the number, the given number, from those many number of 9's. Okay, so that is how you compute the r minus 1's complement in the case of a decimal number system. Okay, as an example, so 9's complement of a decimal number is obtained by subtracting each digit from the number 9. So as an example, let us consider the case of 5, 4, 6, 7, 9. Okay, so let us consider the case of how do you get the 9's complement of, the problem is how do you get the 9's complement of 5, 4, 6, 7. Okay, so by definition, if you consider r minus 1's complement, if you go by definition, it will be what? R power n minus 1 minus n. This is by definition r minus 1. So in this case, what is r? 10, right? We are talking about the decimal number 5, 4, 6, 7, 8. So r is 10 there. So if r is 10, so this small n here represents the number of digits in the given number. So how many digits are there? 1, 2, 3, 4, 5, 6. So this r minus 1's complement, in this case 9's complement of this number, can be represented as 10 power, how many digits are there? 6 digits are there. 10 power 6 minus 1, 10 power 6 minus 1, minus this number, minus the given number, 5467. You are going by definition. Okay, so 10 power 6 will have 1 followed by 6 zeros. From that you are subtracting 1. So what will be the value of this term here in the parentheses? How many 9s will be there? 5 9s will be there. 5 9s or 6 9s? 1 followed by 6 zeros. You are subtracting 1 from it. So how many 9s will be there? How many 9s will be there? 1 followed by 6 zeros. 10 power 6 is this, right? Subtracting 1 from it. So what you do? Take carry. Okay, so here 10 minus 1, 9 becomes, 9 becomes, 9 becomes, 9 becomes, 9 becomes, and final number will be 9. So how many 9s are there? How many 9s are there? How many 9s are there, man? 6 9s are there. So from 6 9s, you are subtracting this number 546 700. So what is the 9's complement now? From this number, you have to subtract 546 700. So what is the value comes? 9 9 here, 2 here, 9 minus 6 3 here, 9 minus 4 5 here, 9 minus 5 7 here. So the 9's complement of this number is 753 You're not able to see? 9 minus 5. Oh. So I do this kind of mistakes. 9 minus 5, 4, right? 9 minus 5, 4, right? So the answer is 453299. Online guess, is it correct? Online guess, is it correct?
Yes, sir.
Okay. So this is how you do the compute the 9's complement of a given number. Yes. So this is the rough straight way of doing it. So instead of going all through this procedure, just identify the number of digits in the given number. Just subtract the given number from those many number of 9s. That's it. Okay. So that is the approach. Go further. Take one more example. Can you compute the 9's complement of 0, 1, 2, 3, 9, 8? 9's complement of 0, 1, 2, 3, 9, 8. 9's complement of 0, 1, 2, 3, 9, 8. Online guys, you also try to do workout with me. 9's complement of 0, 1, 2, 3, 9, 8. 9's complement of 0, 1, 2, 3, 9, 8. So how many digits are there? First of all, you identify the number of digits as it is given in the number. Anybody? How many digits are there here? 5? 5 digits are there. 5 or 6? Take the number as it is given. Take the number as it is given. So how many digits are there in the number? 6 digits are there. So subtract the given number from 6 number of 9s. That's it. Don't think much there. Okay. So anybody, what is the answer? So just identify how many digits are there in the given number, and based on that, just simply subtract the given number from those many number of 9s there. So answer for this problem will be subtract from 6 9s 0, 1, 2, 3, 9, 8. Therefore, the 9's complement of this number will be 987601. All of you got it? Online guys? Online guys?
Yes, sir.
Now, so for the case of binary numbers, what happens? For the case of binary numbers, what happens? The radix of the system will be r equal to 2. Therefore, r minus 1's complement will be 1's complement. All of you agree? So in the case of a binary number system, the radix is 2 there. Therefore, the diminished radix complement will become 1's complement. And all of you know how to compute the 1's complement. Here we'll roughly see what is the procedure. So 1's complement of a given binary number, capital N, is given as 2 power n minus 1 minus n. This is by definition, right? 2 power n minus 1 minus n. Okay. So what is 2 power n? 2 power n, depending on the values, 2 power n will be 1 followed by those many number of zeros. Do you agree or not? 2 cube. So 2 power n will be always 1 followed by those many given number of digits of zeros here. So 2 power n will be always 1 followed by n number of zeros. If n is the small n is the number of digits in a given binary number. So 2 power n will be 1 followed by so many zeros there. Then for 2 power n minus 1 will be binary number with n number of ones, where n is where small n is the number of digits in the given number. So by procedure, by definition, if you want to compute, so what you have to do, first 2 power n minus 1 you have to do, then from that value you have to subtract the given binary number. That is the approach. But you know the simplest way of doing this. So what is the best, easiest way of doing this? Replace zeros with ones and ones with zeros. Okay. So you will get the ones complement. As an example for that, ones complement of 1011 followed by 000 will be also to replace 0 with 1 and 1 with 0. Okay, this will be the ones complement of that. Similarly for this one, this will be the ones complement. Yes, please take these two examples there. For the case of binary number system, ones complement of 1011 followed by 000 will be so r minus 1's complement of 1011 followed by 000. This is a binary number which is going to be. So normal procedure is what? By definition, if you go, the definition says r power n minus 1 minus the given number. So in this case, r happens to be 2. So how many digits are there? 1, 2, 3, 4, 5, 6, 7 digits are there. So r power n will become 2 power 7. 2 power 7 is 128. 128 in binary, how do you represent? 128 in binary, anybody? So I'll just show you our 128 in binary. So 2 6 are, 2 4 are 0, 2 32 are 0, 2 16 are 0, 2 8 are 0, 2 4 are 0, 2 2 are 0, 2 1 are 0. So what do you see here? 1 followed by how many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros are there. So r power n will be 1 followed by 1, 2, 3, 4, 5, 6, 7 zeros. Okay, that is 2 power 7, that is 128. So from this you have to subtract 1. From this you have to subtract 1. This term I am evaluating. So what it becomes? I cannot subtract 0 from 1. You are doing binary subtraction here. So what I do, I am taking carry here. So carry, when you take a carry, it becomes 1 0. 1 0 is what in binary? 1 0 is 2. 1 0 is what? 2. So what it becomes now? 2 minus 1 becomes 1. Here it will be 1, 1, 1, 1, 1. So how many ones will be there? 7 ones will be there. Huh? 1, 2, 3, 4, 5, 6, 7 ones will be there. So this will be the result of this operation in the parent system. From this you have to subtract this number. Okay. So from that you have to subtract the given number. That is 1 0 double 1 followed by 000. You have to subtract the given number. This is my given number n there, which is this number here. Which is this number here. So what is this value? This is 2 power 7 minus 1. You are following? From that I am subtracting. From that I am subtracting the given number. Okay. So what is the result? Anybody? 1 here, 1 here, 1 here, 0 here, 0 here. This will be 1 here. This will be 0 here. So is it correct? Okay. So this is the by definition. How do you compute? So instead of this, the simple procedure says, whenever you want to perform the ones complement, the simple procedure says just to replace ones with zeros and zeros with ones. That's it. Okay. So I can write directly in this case. The ones complement will be simply I am replacing zeros with ones there, ones with zeros there. So this will be the ones complement. Fine. Am I clear? So this is the method. This is the procedure by following method. And here we are doing it directly. Simply replace ones with zeros and zeros with ones. Okay. Am I clear? How to do by definition and how to do directly. Clear? Now, going further. Similarly, we can have R's complement. Now you already know the definition of R's complement. R's complement is simply R power n minus n. Okay, R power n minus n. Okay. So let us do with an example. Tens complement of 2389. So tens complement of 2389. Tens complement of 2389. So we are doing R's complement now. R's complement. As an example for that, example for this, tens complement of 2389. You want to do the tens complement of 2389. So how do you do? By procedure, by definition, if you go, R's complement is defined as, anybody? Is defined as R power n minus the given number. Agree? So what is R in this case? R is 10. So how many digits are there? 4 digits. So small n is 4 there. So R power n becomes 10 power 4. That is equals to what? 1 followed by 4 zeros. From this number, you have to subtract this given number. So R's complement will be, from this, you have to subtract the given number, that is 2389. Okay. So what will be, this will be 0, right? So this will be 1, right? Yes. What will be value here? 1 here. Here. 1 here. Here. 6 here. Here. 7. 7, 6, 1, 1. Okay. So this is how you do the R's complement of a given number. Fine. So we are talking with respect to base 10 system. Okay. We are talking with respect to base 10 system. 7613. Right? Correct only? Right? Any doubts? No, no. Let us go further. So take this small note. So this is very important observation. How can you write the tens complement directly? This procedure is illustrating that. Okay. So the tens complement of a number of a decimal number n can be found by leaving all the least significant zeros unchanged. This is the procedure for writing the tens complement directly. So first, what you have to do, observe the number and leave all the least significant zeros unchanged. Least significant zeros means those digits which you see on the right side. If there are any zeros coming there initially, so those zeros will be left unchanged. Okay. Then subtracting the first non-zero least significant digit from 10 and subtracting all higher significant digits from 9. Okay. So this is the method of writing the answer directly, where whenever you are asked to find the tens complement of a given decimal number, what you have to do is first leave all the least significant zeros unchanged, subtract the next most non-zero least significant digit from 10 there, and the remaining all higher significant digit is subtract from 9. Okay. So as an example for this, let us work out the tens complement of 0, 1, 2, 3, 0, 1, 2, 3, 9, 8. Just illustrate the shortcut of writing it. Tens complement of 0, 1, 2, 3, 9, 8. This is the number which is given to you. Okay. And how do you write the tens complement directly? Okay. The procedure says leave all least significant zeros unchanged. Zeros unchanged. Okay. So are there any least significant digits which are zeros here? Least significant means which are on the right side of the number, right? So are there any least significant zeros here? So the first condition is not being satisfied by this number. So I will ignore this. Then the procedure says next non-zero least significant digit, subtract from 10 as per the procedure. Let's have a look at the procedure. Subtract the first non-zero least significant digit from 10. Okay. Now, since there are no least significant zeros here, the first step is invalid for us. Now, let us come to the next step. Next non-zero least significant digit, you have to subtract from 10. So, here we have a non-zero least significant digit here, which is non-zero. Therefore, you have to subtract this number from 10. So, the first digit of the 10's complement will be 2. 10 minus 8, 2. Then the procedure says remaining all digits, subtract from 9. So remaining whatever digits you are remaining here, those digits you have to subtract from 9. So 9 minus 9 becomes 0 here, 9 minus 3 becomes 6 here, 9 minus 2 becomes 7 here, 9 minus 1 becomes 8 here, 9 minus 0 becomes 9 there. So this is the tens complement. How do you write directly following this method, which I wrote here? First, what you have to do, leave all least significant zeros unchanged. If there is a 0 here, you should have kept it as it is. Now in this case, we have 8 here. So I am taking the next method, next procedure. Okay, next non-zero least significant digit has to be subtracted from 10 there. So I am subtracting this non-zero digit from 10. Okay, 10 minus 8 has become 2 there. Then remaining all digits you have to subtract from 9. Remaining all digits I am subtracting from 9. So this is the shortcut of writing this. Yes? Am I clear there? Am I clear there? Is the procedure clear to you? Now, once you know the tens complement, you can easily get the. Can you work out the other one? Other example? Tens complement of 246,700. Tens complement of 246,700. Tens complement of 246,700. Somebody now use the procedure directly and tell me the answer. Anybody? So the procedure says leave all the least significant zeros unchanged. So in this case, how many least significant zeros we have? There are 2 least significant zeros. So they should be kept as they are. The first non-zero least significant digit you have to subtract from 10. So 10 minus 7 becomes 3 here. Then remaining digits, whatever you have, those digits should be subtracted from 9. So 9 minus 6 becomes 3 here, 9 minus 4 becomes 5 here, 9 minus 2 becomes 7 here. So the number is 753300. So this is how you write the tens complement of a given decimal number directly. So is the procedure clear to you? So you should be able to do this quickly, right? Similarly, you can write a procedure for getting the 2's complement of the binary number as well. So 2's complement of the binary number, let us see some examples for that. Same approach. So leave all the least significant digits unchanged. If at all there are zeros there, those should be kept as they are. And the first one unchanged. First one, if it is there, it should be kept as it is. And remaining all ones, you can interchange the numbers. Remaining all digits, you have to interchange the numbers. Okay. So as an example for that, 2's complement of 1101100. Okay. Let us do this. 2's complement of 1101100. 1101100. So the procedure says leave all least significant zeros unchanged. Online guys, are you following? So how many least significant zeros are there? There are 2 least significant zeros. So they should be kept as it is. And the procedure says next, the first one unchanged. First one, if it is there, it should be unchanged. So is there a first one now? First one has come. So keep it as it is. Then remaining is complement. Remaining digits interchange 1 and 0. One with 0 and vice versa. And vice versa. So what will happen for the remaining 4 digits here? Wherever 1 is there, I should replace with 0. Wherever 0 is there, I should replace with 1. So this will be the 2's complement of the given number. Yes? Online guys, are we following the discussion? Online guys.
Yes,
Yes,
sir.
sir.
Yes, sir.
So is the procedure clear to you there?
Yes, sir. Clear.
Now let us go further. Now subtraction with complements. So that is the reason why we have studied how to compute the complements of a given number system. So once we know how to get the complements of a given number system, then we can use that in doing subtraction operation. So the subtraction of 2 n-digit unsigned numbers m and n in base r can be done as follows. So these are the steps in doing subtraction whenever you are using the complements of a number system there. So add the minuend m to the r's complement of the subtrahend. So all of you know what is minuend and what is subtrahend, right? When you are subtracting, say for example, m minus n. Okay, so this n is called as subtrahend. This m is called as minuend. So the number which you are subtracting, that is called as subtrahend. The number which you are subtracting from, that is called as minuend. You are following? So here, the number which you are subtracting, in this case it happens to be 9. You are subtracting 9 from m, right? M minus n, when I say, I am subtracting the number n from the number m here. So what you have to do? Take the r's complement of the subtrahend. So you have to take the r's complement of this number n here, and that r's complement, what you have to add? You have to add to the minuend which is given there. Okay. So the first step says add the minuend m to the r's complement of the subtrahend. This performs this operation m plus r power n minus n. Okay, fine. Then if at all m is greater than or equal to n, the sum will produce an n carry. So based on the value of the number there, if at all m happens to be greater than or equal to n, the sum will produce an n carry there, which is n carry r power n, which can be discarded. So if at all there is a carry generated because of this addition in the first step, so what you do, simply discard the n carry which is generated, and whatever is left, that will be the result of the operation m minus n. Now, if there is no carry generated, the second step is illustrating what you have to do whenever there is a carry generated. Okay, so whenever there is a carry generated, what you have to do, just discard the carry, and whatever is left, that is the answer for the operation. And if at all there is an n carry not generated, so in that case, the actual answer will be the negative of the r's complement of the given result. Okay. In that case, the answer would be, if at all there is no n carry generated, in that case, the actual answer will be negative of the r's complement of the result of the operation. Okay, so this is the procedure. You can, I will share the PDF with you. Okay, just to understand the procedure. But this procedure you should know how the subtraction is being done at the lowest level. You should know it. So that is the steps in the procedure there. So just go through the steps once again when I share the PDF on your class tips there. So here we will take a small example and try to understand using the binary. So let us subtract 2 numbers. So let us subtract 2 binary numbers. So the first number which is given as x equals to 101 0100. X is given as 101 0100, right? 0100. Y is given as 1 followed by 4 zeros, 11. Y is given as 1 followed by 4 zeros, 11. 1 followed by 4 zeros, 11. So you first will try to understand how do you do x minus 1. How do you do x minus 1? So here the first thing is this. So in this operation x minus 1, x becomes the minuend and y becomes the subtrahend. You are subtracting y from x. Y becomes a subtrahend, right? So what the procedure is, take the r's complement of the subtrahend. So in this case, what is the type of the number system? It is a binary number system. So you have to consider the 2's complement of y. First, you have to get the 2's complement of y. So what will be that? The procedure says leave all the least significant zeros unchanged. So are there any least significant zeros? No. Then the procedure says the first one as it is. The first one you have to take it as it is. Therefore, the first one remains as it is. Then the remaining is what you have to do? Take the complement of the remaining bits. Okay. So this one becomes 0 here. 4 zeros becomes 4 ones there. And finally, the last one becomes 0 there. So this will be the 2's complement of y. You are following? So the next procedure says, how do you do x minus y? The procedure says, how do you do x minus y? From x, just add the 2's complement. 101. To the minuend 101 0100 to the minuend, add the 2's complement of the subtrahend. So this is the 2's complement which we add. Just add it 0 11 11 01. Just add it. So you are not doing subtraction, you are doing addition once again. But how are you doing the addition? By taking the 2's complement of the subtrahend. Okay. Now, so this will be 1, this will be 0. 1 plus 1 is 2. 2 in binary, how do you write? 1 0 1 0. Okay. So 0 comes here, 1 goes here. So 1 plus 1 is 2 once again. 0 comes here, 1 goes here. 1 plus 1 is 2. 2 plus 1 is 3. 3, how do you represent in binary? 1 1. So 1 comes here, 1 goes here. 1 plus 1 is once again 2. 2 in binary is 1 0. So 0 comes here, 1 comes here. Now 1 plus 1 is 2. 0 comes here, 1 will be the carry. This is the carry. So the procedure is whenever there is an n carry, whenever there is a carry generated, what you do? Simply discard this carry. Simply discard it. And whatever is remaining, that is the operation of, that is the required result. So this is the result. So whichever I circled there, that is the result. So the answer for this operation is 001 0001. Online guys, are you following? Online guys, are you following?
Yes.
Yes, sir.
Am I clear with the procedure? How to perform subtraction using 2's complement method?
Clear,
Yes.
sir.
Okay. Now let us do the other way. Y minus x if you want to do. So can somebody tell me what is the value of x once again? What is the value of x? Somebody please get a bit louder. 1 0 1 0 1 0 0. So this is the x value which is going to. What is the value of y? What is the value of y? 1 4 zeros 1. So this is the value of y which is given to you. So in this case, let us see how you perform y minus x. The other way. I am doing the other way. Now in this case, which is minuend, which is subtrahend. So this becomes minuend now. And this becomes subtrahend. Okay. So what does the procedure say? Take the r's complement of the subtrahend and add it to the minuend. So we have to take 2's complement of x. So 2's complement of x, how do you write? I am writing directly. So leave all least significant zeros unchanged. There are 2 least significant zeros. So those zeros I keep them as they are. The first one unchanged. The first one also I keep it as it is. Remaining is you just take the alternate. Okay. So 0 becomes 1. 1 becomes 0. 0 becomes 1 and finally 1 becomes 0. So this is the 2's complement of the given x there. Now let us perform this operation y minus x. So how do you do? Y minus x, I do first take the value of y, 1 followed by 4 zeros, followed by 2 ones there. To this you add what? You are adding what? 2's complement of x. 2's complement of x is this value. So 0, 1, 0, 1, 1, 0. You are adding this. So what will be the result of the operation? 1, 1, 1, 1, 0, 1, 1. So is there a carry generated? No, there is no carry. So what will be the answer? Is this the answer? No. So whenever there is no carry generated, the answer is what? The answer equal to, the correct answer will be negative of 2's complement of this result which you got. Negative of 2's complement of this result which you got. So 2's complement of this number will be, the least significant one will remain as it is. So remaining ones you have to interchange with 0. So the actual answer will be 0, 0, 0, 1, 0, 0. This will be the actual answer. Negative of 0, 0, 1 followed by 0, 0, 1. This will be the actual answer. Negative of 2's complement of the result which you got from the operation. So please understand, in the process of subtraction, you have to observe whether is there any carry being generated or not. Because there is a carry generated, just discard the carry and whatever is remaining, that is the answer. Because there is no carry generated, in that case, the actual answer will be the negative of the result which you got. Negative of the 2's complement of the result which you got. Am I clear? Online guys, am I clear there? Online guys, am I clear?
Yes, sir.
Are you doing along with me? Online guys, are you doing along with me, guys?
Yes, sir.
Yes, sir.
Please put a notes and do along with me, otherwise it becomes a problem. Okay. So approach is clear? Guys there, offline. Chestnara? No. So how do you represent negative numbers? Till now we are talking about positive numbers only. Okay. Now how do you represent negative numbers? Okay. So normally in everyday computation we have to deal with negative numbers as well. So there should be a representation for negative numbers as well in our binary system. Okay. So whenever we are discussing the subject of digital electronics and logic design, mainly we will be talking in terms of binary numbers. So you should have a representation of negative numbers also in binary number system. And all of you know from your previous subjects, you can represent negative numbers. There are different ways of representing negative numbers, right? So you have any knowledge of how you represent negative numbers? What are the representations employed there? How can you represent negative numbers from your programming course? Any representations you know? Whenever you want to represent negative numbers? Yes? There are, you heard this term, signed one's complement representation, signed two's complement representation. Did you ever heard these terms? Signed one's complement representation, signed two's complement representation. Did you hear these terms? Yes, yes or no? Answer the question now. Yes or no? Did you hear or not? Have you ever heard these terms or not? Sign one's complement, sign two's complement, yes or no? Please respond, guys. Offline, guys, please respond. Talk to me. Yes, sir. So let us have a relook at those representations as well once again. Why? Because we will be dealing with the negative numbers as well in our discussion. So we should know how to represent negative numbers. So to represent negative integers, we need a notion for negative values. So in ordinary arithmetic, a negative number is indicated by the negative sign in front of the number. So whenever in your ordinary arithmetic, whenever you represent a negative number, how do you represent? Put a negative sign in front of it. That indicates that it's a negative number. And a positive number is represented by a plus sign in front of it. Okay. So this is the normal ordinary arithmetic representation. So computer represents everything with the binary bits. In computers, everything is represented using bits there. So it is customary to represent the sign with a bit placed in the leftmost position. Okay. So the leftmost digit of the binary number, we use it for representing the sign of the number. So whenever the leftmost digit is 0, that represents that the number is a positive number. If the leftmost digit happens to be a 1 there, that represents that the number is a negative number. Okay. So that is the normal convention which we follow. So sign bit 0 is for positive and sign bit 1 is for negative numbers. Am I clear there? So we are using the leftmost digit of a binary number for representing the sign of the number. If the leftmost digit happens to be 0, it indicates the binary number is a positive number. If the leftmost digit is a 1 there, it indicates that the number is a negative number. Okay. Now going further, there are 3 representations of negative numbers. Okay. The first one is called as signed magnitude representation. The second one is called as signed ones complement representation. And the third one is called as signed twos complement representation. So whenever you want to represent negative numbers, there are 3 approaches for doing this. Either you can use signed magnitude representation, or you can use signed ones complement representation, or you can use signed twos complement representation. So these are the 3 methods of representing negative numbers. So am I clear with these 3 representations? So let us understand how do you represent numbers using these 3 representations. Okay, negative numbers using these 3 representations. Okay. Right, let us understand the procedure that will make the concept clear to you. So the signed ones complement representation can be obtained by complementing all the bits of a positive number, including the sign bit. So how do you represent the sign ones complement representation? To get the sign ones complement representation of a given number, what you have to do is complement all the bits of a positive number, including the sign bit. Okay, so that is a procedure for getting the signed ones complement representation of a given number. Similarly, the signed twos complement representation is obtained by taking the twos complement of a positive number, including the sign bit. So this is how you represent negative numbers. So let us understand this procedure using an illustration. For doing that, let us see, take an example of representing number 9. So negative number representation. The topic we'll try to understand is negative number representation. In binary system. Okay, so let us take -9 you want to represent. Let us take the example for -9. So first what you do is, whenever a number is given to you, to represent this number in the 3 different representations, first consider the positive value of this number. So positive value of this number will be +9. So in this case, let us use 8 bits for representing the number. Let us use 8 bits for representing the number. I'm saying that I represent this number using 8 bits. So whenever I do that, so how do you represent? If you are using 8 bits, the number 9 can be represented as 1001. This is number 9 in binary. Do you agree? Whenever I am using 8 bits there. You are clear? This is 9 representing the binary, where I am using 8 bits for the representation. Now I want to represent -9. I want to represent -9. So there are 3 different methods of doing it. The first one is signed magnitude representation. So in the signed magnitude representation, what you do, take the magnitude as it is. The only change you have to make is make the most significant digit 1, saying that it is a negative number. Okay, so in this case, the sign magnitude representation will be 1001. This will be as it is indicating the magnitude there. And this most significant bit, what I do, I'll make it as 1, indicating that it is a negative number. So this is signed magnitude representation. Now, second one is signed ones complement representation. Signed ones complement. So how do you get the signed ones complement? Take the positive binary of the given number. Then what you do, take the complement of the entire number, including the sign bit. Take the complement of the entire representation, including the sign bit. So if you take the complement of it, take the ones complement of this, what will be that? 0, 1, 1. I am looking at this number, +9. To this number, +9, how do you represent? Take the complement of that. That's it. That will give you the signed ones complement representation. So that will be 1, 1, 0, followed by 4 ones, like this. So this is the signed ones complement representation of -9. This is the signed ones complement representation of minus. Are you clear? Are you clear, guys? Offline, online, guys. Are you clear? Third one, signed 2's complement representation. So whenever you want to do the signed 2's complement, what you do? You observe how the positive number is represented and take the 2's complement of the entire number using including the signed bit. Take the 2's complement of this binary pattern. That's it. That will represent the minus 9 in 2's complement representation. Okay. So the 2's complement of this will be what? 1 will remain as it is. 2 zeros will remain as they are. The first one will be, this becomes 0. Remaining all 4 bits will be 1. So this is the signed 2's complement representation of minus 9. Am I clear with the procedure? Online guys? Online guys, offline guys, am I clear? Is the procedure clear to you?
Yes, sir.
Is the procedure clear to you? Any doubts there, online guys?
Sir, sir, in the signed to complement, I think it should be 1, 1, 1, and 0, no, sir.
So just now, just read the procedure. Signed 2's complement representation is obtained by taking the 2's complement of the positive number, including the signed bit. So you have to take the 2's complement of the number, positive number, including the signed bit. So this is the positive number representation of 9 there. So take the 2's complement of this binary pattern as it is. Yes, including the signed bit. So same 9, same minus 9 can be represented differently in different parts. Yeah, in computer, normally the practice is the signed 2's complement representations used. In all computer arithmetic, the system, how it does is, it will consider signed 2's complement representation. So whenever computer performs the subtraction, just now we have seen, right? So when you are doing subtraction, are we using 2's complement or 1's complement? We are using 2's complement. So that will represent when the numbers are represented using signed 2's complement by the computer system. Whenever the system is performing some binary arithmetic for a subtraction operation, we represent the number using signed 2's complement representation. Am I clear, guys? Online guys? Am I clear? Yes? I'm not getting any response. So this is the signed magnitude representation of minus 9. This is the signed 1's complement. This is the signed 2's complement of minus 9. Yes? All of you agree? All of you agree, online guys?
Yes.
Yes, sir.
So let us stop the discussion here. So I have a small table here where I am representing numbers in signed 2's complement, signed 1's complement, and signed magnitude form. Please have a look at this table when I share this PDF on the Teams there. Maybe today I share the PDF on the Teams. Just have a look at this table. We'll draw some inferences or some observations from this table in the coming class. So we'll stop the discussion here. Remaining things we'll see in the coming class. So do you want me to save this open board material? Not required, no? Online guys, you want this to be saved? I'm already, I will be putting the PDF. PDF also contains this, but yes, ma'am.
Sir, in the 2's complement, the least significant number is 1, no, sir.
So that is what the first one is kept as it is unchanged.
Then the next 2 digits zeros will be changing to 1, no, sir.
These are not least significant digits. These are the next significant digits. These are not only the least significant digit 0 will be unchanged. Only the least significant 0 will be unchanged. That is the procedure.
Then
if at all there was a 0 here, I should have kept that 0 as it is.
The next remaining digits should be complement, no, sir.
That is what I am doing. No? The first one I am keeping as it is. There are 2 zeros here which are not least significant zeros. Therefore, I am taking the complement of them. I am keeping. Sorry, I should take the complement. I apologize. Yes, I made a small mistake. You corrected, right? That's correct, man. You are correct. So it should be 2 ones here. You are
Yes.
correct, man. Please correct when I am doing some mistakes. Please, you should tell me immediately. So I am in a flow. I don't see. In the notes, it's correct. When I am doing, I made a mistake. Yeah. What is your name, man? You corrected just now.
Vikas.
Yes. Thank you, man. So it should be what? 1 followed by 1, 1, 0 followed by 4 ones. Am I clear? You are correct, Vikas. You are correct. This is the sign
Yes,
to
sir.
stop. You are correct, man. So that means people are following me. Yes. So thank you, Vikas, and thank you everyone for listening to me. Remaining things we'll try to discuss in the coming class. But let me download the attendance before we leave.